Hello, this is Ganesh, and you're watching Optimal Code YouTube channel. And today we are going to start our competitive programming journey, and we start solving very basic problems, and we increase the rating day by day. And today we are solving a question of rating 900, and the problem name is Motcha and Math. And I actually took the question from Codeforces platform. So if you don't have an account in Codeforces, please create an account on that. So let's get into the video. Okay, let's get started by reading the question. So the question name is Mocha and Math. Okay. This is all the prerequisite. And what's the main question is, Mocha will get a sequence A of length n, and she can do some operations on that sequence. Like for each operation, she can select an interval L to R, and she can bitwise AND with the first value in that interval and the last value in that interval, and second value in that interval with last but second value. If you see the example, there is an array. They provided an example. There is an array A1, A2, A3, A4, A5. And what Mocha will do is she can select an interval. She can select interval at many number of times, like 0, 1, 2, infinity times. And uh, if she select the interval 2 to 5, then the new array will become A2 bitwise and with A5. A3 will get replaced by A3 bitwise and A4. And A4 will get replaced by A4 bitwise and A3. And A5 will get replaced by A5 bitwise and A2. So in this way, she can do this operation many number of times, infinity times. And what we have to do is we have to print the minimum value of the maximum value in that sequence. This part is tricky. We have to be careful. We should not return the maximum value or minimum value. We have to return the possible minimum value of the maximum in that sequence after any number of such operations. If you see the constraints, n is from 1 to 100. Like you can literally do brute force approach. Like you can put three for loops, like take every interval, and in every interval you can find the maximum, and after that loop you can find the minimum. Yeah, you can do that, but what we are focusing in this video is the optimal solution, like the tricky solution. And they provided an example, and you can check that out. And before we jump to the solution, let's clear the question first. Okay, like in what way we can modify the question is, we will get an array like this. uh, let's say, oh yeah, we will get an array like this, and for each operation what we do is we select an interval. Like if we select an interval like this, then array will be modified as a1 bitwise and of a2 and a5. That means the first element bitwise and with last element, the second element is bitwise and with last but second element, right? So now a3 will get replaced by a3 bitwise and a4, and a4 will get replaced by a4 bitwise and a3, and a5 will get replaced by a5 and a2, right? And our new array became like this, right? And what we have to do is, and we can again choose an interval. We can again choose an interval. For suppose if I choose an interval like this, then what it will become is a1 bitwise and with this thing, right? A2 a5 bitwise and with the same number, then it will become again the a2 bitwise and a5, right? Simple principle, right? If you bitwise and with the same number, we will get the same result, right? In the same way, if we bitwise and with a2 and a5 and a2 and a5, then it will become a2 and a5, right? And this will get replaced by a3 bitwise and a4 and bitwise and with a1, right? In this way, we can choose any number of times and any such interval, and for each operation we will do like this. Like the first element will get bitwise and with last element. So in this way, what we can get a conclusion is, at a worst case scenario, like what can be the maximum possible value some index can get in that array. If we observe carefully, after infinity operations, the a1 may become the bitwise and with all the elements, right? A1 will become bitwise and with all the elements, because we don't know such combination of we don't have the limit of number of operations. So we have, as we have unlimited number of operations, A1 can bitwise and with any of the other numbers. And similar case for A2. A2 can bitwise and with many other. And what we can simplify? The worst case for A1 is this, right? A1 bitwise and A2, A3, and A4, A5. And similarly, if you see for A2, A2 can also A2 can also bitwise and with A1, with itself, with A3, with A4, with A5, right? So the worst possible answer for A2 also this one. Same for A3, same for A4, same for A5. So what we get is after infinity operations, you will get this thing. This thing you can get at first index or second index or third index, fourth index or fifth index. You can get this. So now let's get into the second step of the solution. And from first step, you can conclude that the worst possible value uh, a one index in that array can get is the bitwise AND of all the remaining elements. Like it can bitwise AND with itself also. So the worst possible scenario for every index will be this one, right? That thing is clear. And now let's get into the step two. And if we see the fundamental rule of the bitwise AND operation, and you can see it by your intuition also, it's not any principle or anything that you should memorize. Like if you do bitwise AND with two elements, the maximum value of the bitwise AND result can be the minimum value of the A1 and A2. Clear? Am I clear? When I do bitwise AND operation for two elements, the result cannot go beyond the minimum of these two values, right? So, okay, now can I say if I add another element, oh sorry, if I add bitwise AND with another element, and now minimum will also be checked by three elements. Am I right? So now when I include A3 into the minimum list, the result can be same, or I will get a new minimum, or I'm saying that A3 can be the new minimum. So the maximum value of the A1 and A2 will get minimized when I introduce new elements, right? I'm sorry, the maximum of result of the bitwise AND operation will be minimized if I introduce two elements. I can say that, right? If I add one more element, I'm sorry, I keep on adding the and symbols. Sorry. If I add one more A4 element, I will be getting the same minimum, or I will getting the new minimum. The answer won't be more than that, right? More than the answer in previous case. When I add A4 can be the new minimum, so the maximum value of the result can be updated as new minimum. Is that making sense? It can be a little bit tricky, but if you spend time with it, and you will get cleared with it. So as we already seen in the first step, the worst possible scenario is the bitwise AND of all the elements, right? What I can say, we have to what our goal is, we have to minimize the maximum value, right? That means we have to take the worst possible value at each index. If we take the worst possible value at each index, what I can get is the result of the bitwise AND operation can be as minimized as much. Am I right? When I'm taking the worst possible answer, like when I'm including all elements in my array, like it can be A5 or some A100 also. When I'm doing such result, my minimum, my maximum, the maximum of this result is minimized as much. Right? Am I making sense? If we clear with this thing, uh, the question is completed. So what I can say is our goal, our result is nothing but the bitwise AND of all the elements present in that array. Am I making sense? Yeah. Now let's get into the code part. If I get into the code part, yeah, you already know the prerequisites. I'm taking number of test cases as input, and for each test case, I'm executing this function, solve function. So for each test case, I'm taking the number of integers in that array, and I'm taking the values in that array, and I'm storing in ARR variable array, and I'm handling a edge case that if n is equal to 1, it can bitwise and with itself, right? So I simply print the ARR of 0 with its only element. And if the n is not equal to 1, I initialize my answer with the first element, and I start from I is equal to 1, and I continue traversing up to n, and I will bitwise and with all the elements, and I will return the and I will print the result. Yeah, it's that simple, and you will get accepted with all the test cases. So this is it for the video. So let's meet in the another video discussing another important or another interesting solution in the CP journey. So I'm planning to make a DSA playlist also if I do get support. So please support me. Please like the video. Please share it to your friends and please subscribe the channel. Yeah, thank you.